Hi guys. The other thing that we are going to be working on this week, other than operations with polynomials, is going to be properties of exponents. This you may not have seen since Algebra 1. Sorry about the noise in the background. My dog is playing with a bone. I guess it's more of an antler. Anyway, ow. Rude dog. So, we're just going to go over two of the most common ones right now. Two of the most common properties. So the first is multiplying like bases. So that's when you have something like x to the third times x to the fourth. So if you remember, an exponent really is just telling you how many times to multiply something by itself. So if you have x to the third, that's saying x times x times x. And if you have x to the fourth, that's x times x times x times x. And you're just multiplying those together. So if you count up how many you have all together, you have x to the seventh. So essentially when you multiply like bases, you add their exponents. It's really just that simple. So over here in my example, one thing to keep in mind is that when you have coefficients or the big numbers, like regular size numbers that are attached to the variables, you just multiply those together. They're just numbers. So the same rules that have always apply to them. So you do 4 times 8 times 2, which gives you, I said the wrong thing. 4 times 2 is 8, times 2 is 16. Sorry about that. And then I'm going to combine my x's. So if they don't have an exponent, it's the same thing as having a 1. So then I just add them up. I've got 1 plus 1 plus 2, which is 4. So x to the fourth. Then I have my y's. And again, this one doesn't have one, so it's like a 1. So it's 1 plus 2 plus 4, which is 7. And then you're done. Ta-da! See how easy that was? So awesome. As far as dividing like bases, that would be if you had like x to the fifth. We'll just do y to the third over x squared y to the sixth. Looks good. Let's throw some coefficients in there too. Let's do like 2 and 6. Okay. So starting with my coefficients, I'm still just going to divide them. So 2 divided by 6 is the same thing as 1/3. But one way you can think of that is that it's kind of like 6 is bigger, so it's kind of like 6 divided by 2, with the 3 just staying on the bottom. I worry that might confuse you. So just try and simplify. 2 divided by 6 is 1/3, so the 3 stays on the bottom of the fraction. As far as my x's go, that means the same thing as, like, we'll just do a little 5 x's on top and 2 x's on bottom. So when you have a number divided by itself, it equals 1. So they cancel out. So that would just leave 3 x's on top. So essentially what you're doing is you are subtracting. So when you divide like bases, you are subtracting their exponents. So 5x to the fifth divided by x squared, that's going to leave me with x to the third, because 5 minus 2 is 3. The only difference with the y's is that I have more y's on bottom. So when these start to cancel out, I'm going to be left with y on the bottom. So when you're doing this, make sure you ask yourself, are there more on top or on bottom? Because wherever there's more of them, that's where that variable is going to stay. And then you still just subtract. So 6 minus 3 is 3. That way you avoid negative exponents, which makes your life easier, because we haven't really gone over negative exponents. So here, I just have 2 divided by 4 for my coefficients, which is 1/2. Then I'm going to do my x's. So remember, if there's nothing there, it's like a 1. So there's more x's on top because there's 4 of them on top. And then I just subtract and I get 3. And then for my y's, there's more of them on bottom. So I'm going to subtract and do 3 minus 2 is 1. You could put a 1 here, but to be honest, we don't usually write a exponent of 1. So I'm just going to leave it as y. So it's just x cubed over 2y. Down here is where they get it, all that gets kind of put together. So what you're going to do is you are going to combine everything that's on the same level before you do the dividing. So on top, I'm going to go ahead and put all those u's and v's together, and then I'll start subtracting. So it's going to be 2 steps. I'm going to have 4, and then I've got my u's here. So add those together, I get u3. And then my v's, add those together, and I get v5. Then on the bottom, I've got 2u2 and v3. So my next step is to subtract. 4 divided by 2 is 2. There's more u's on top. So I'm going to end up with u1 when I subtract, or just u. And then last, there's more v's on top. And I'm going to subtract and get 2. So this one ends up just being a regular number that's not a fraction, or a regular expression, rather, that's not a fraction. And if it ever happens the other way where everything's on the bottom, or even this way, it's just, you put a 1 wherever the other stuff is gone. Putting it over 1 is kind of silly, like we don't usually write it that way, but if everything was on the bottom, you would just put a 1 on top. So one more example. For this one, I'm going to combine the top again first. So that will give me 4x to the 5th, because I'm going to add these 2 together. Y to the 3rd. The bottom stays the same. So for my coefficients, 4 and 3, they don't simplify. You cannot evenly divide 3 and 4, and they don't have anything in common. So they're just going to stay where they are. Then with my x's, I have more on top, and there's a 1 there, so 5 minus 1 will be 4. Then with my y's, I have the same thing on top and bottom. So 3 minus 3 is just going to end up being 0, which means my y's are just going to disappear. So this will end up being my final answer. 4x to the 4th over 3. There you go. Those are the 2 most common properties of exponents. So I hope that you guys have a good week, and good luck with everything.